Can you correctly arrange oxygen ion, fluorine ion, sodium ion, and magnesium ion correctly in order of the ionic sizes? Do you know why the magnesium has higher first ionization energy than aluminium, even though it comes before aluminium in the periodic table? These are some of the periodic table questions that students come across in respect to chemistry. Today, we're going to be looking into this masterclass of Chemistry 102. We're going to be taking you through 50 highly yielded questions that you will come across in a typical chemistry CBT exam. In this particular masterclass, we're going to look into topics that pertains to the periodic table. We're going to look at the periodic classification, electronic configuration, periodic trends, ionic sizes, ionization energy, electronegativity, and other exceptions that you need to familiarize yourself with. Welcome to Insight Tutorials, where insight meets excellence. Joining with me, take a seat down, take a pen and paper, and be ready to learn even as we kickstart this very masterclass. Every question that I'm going to be treating today, what I advise you to do is that once you see the question, you can pause the video, attempt it, and get your answer ready before I even reveal it. And at the end of each session, you should be able to score yourself how many you get out of 50. Ready to learn. Thank you. My name is Peter Obaji, and I am tutor for today. All right, before we continue, let me give you a brief foundational knowledge as regards the periodic table. In 1817, a man by name Johan Dobereiner, he actually arranged elements in what he referred to as triads. I want to say triads. Triads means three elements in a particular group. He observed elements like lithium, sodium, potassium, and when he saw that this element had the same electron valency in terms of their outermost shell, he referred to them as triads. And second to him was a man by name John Newlands. John Newland in 1864 proposed what we refer to as the law of octaves. The law of octaves. Now, Newland actually picked out like 62 elements and began to arrange them in order of their relative atomic numbers. And then he began to notice that in the course of his arranging those elements, at every 8 elements, there was a similarity in those arrangements. And so he proposed that, he referred to that as what the law of octave. Octave means 8, similarity in the 8 elements he came across in the course of arranging those 62 elements. Next to him is a popular man named Dmitri Mendeleev. If you're a chemistry student, you'll be very familiar with this name, Dmitri Mendeleev. Dmitri Mendeleev was the first person that actually proposed that and gave the proponent that elements are actually arranged in order of their relative atomic masses. All right. And then lastly, we have a man that you need to know his name in respect to this particular foundational knowledge of the periodic table. His name is Henry Moseley. Henry Moseley was the one that finally proposed that elements should actually be arranged in order of their atomic number, as against Dmitri Mendeleev. And when Dmitri Mendeleev actually gave his proponent, he even gave spaces for elements that were yet to be discovered. All right, that there were certain elements that, though he knew the properties that those elements will exhibit, but he did not know what elements that will be. So he gave those spaces. Now, in the modern day periodic table, there's actually a definition by which the periodic table is actually given. So we call that the periodic law. So this is one of the things that you need to know that is very important. And this periodic law states that the physical and the chemical properties of elements is a periodic function of their atomic numbers. So that's to say that the basis for which we are to determine how elements are arranged in the periodic table is in respect to their atomic number, not their relative atomic mass, very importantly. Now, also in the periodic table, the vertical column are referred to as groups, and the horizontal column are referred to as the period. That's to say, if I'm coming down here, I'm dealing with the groups, and if I'm moving this way, I'm dealing with what? The periods. And also, there's also something you need to be very familiar with, that the block that an element belongs to is determined by the subshell in which its last electron enters, right? That's to say that if I do something like 1s2 and 2s2, this is actually the last electron of this particular element in terms of its configuration. So that's how I determine the block. And it's also very important for you to look. We have the various types of blocks. We have the S block, we have the P block, we have the D block, and we have the F block. Now, this S block generally elements that falls between group 1 to group 2 in the periodic table. And you know, group 1 elements are referred to as the alkali metals, and then the group 2 are called alkaline earth metals, where you have the calcium, the magnesium, and so forth. And the P block are elements that ranges between group 13 to group 18. Between group 13 to 18. The D block are elements that ranges between group 3 to group 12. And the F block are actually generally referred to as the lanthanides and the actinides. So they are all very large. As it stands, even till date, elements are still being discovered and are making up in the periodic table. So that's what you need to know very importantly. All right, the periodic table, according to the modern day postulation, asserts that there are 18 groups and 7 periods. It's very important for you to know. Having known that, let's go straight into the questions that we will attempt. We've started the 50 highly yield question. The first one says that the modern periodic law states that the properties of the elements are periodic functions of their dash. A says atomic numbers, B relative atomic mass, C mass numbers, D neutron. Pause the video and tell me what answer it is. All right, it happens that the correct answer to this question is the atomic number. Of course, you should know that the periodic law in the current state defines the periodic table in respect, or defines the periodic table in respect to their atomic what? Number. The relative atomic mass is actually postulated by Dmitri Mendeleev. Now, the second question says that the scientists who arranged elements mainly in order of increasing relative atomic mass was, A says Henry Moseley, B says Dmitri Mendeleev, C says John Newlands, and D says Johan Dobereiner. So we all know that Newlands is actually synonymous to octaves. Henry Moseley is to atomic number. Johan Dobereiner talked about triads of elements. So the person that spoke about relative atomic mass is Dmitri Mendeleev. The third question says that the law of octaves was proposed by dash. A says Rutherford, B says Moseley, D says Dobereiner, and D says Newlands. Well, Rutherford is not the answer. Moseley talked about the atomic number. Dobereiner is to electron triads, triads of elements. It's Newland that spoke about octaves. So that's the correct answer. The next question says, the horizontal rows of the periodic table are dash. A says period, B says group, C says family, and D says block. We all know that the horizontal part of the periodic table is simply regarded to as periods. The group is actually the vertical axis of the periodic table. All right, so we have question 5 to 7 here. Question 5 says, elements in the same group generally possess similar chemical properties because they have the same dash. A says number of neutrons, B says atomic radius, C says outer shell electronic configuration, and D says number of occupied shells. Now, in terms of group, and when we're talking about group, same group, this is a keyword, same group. Number of occupied shell is not the same, because if you're going down the group, in group 1, Group 1, for example, we have hydrogen has 1 shell, lithium has 2 shells, sodium has 3 shells. So this is not correct. Number of neutrons, of course, that's not correct, because in terms of the group, the number of neutrons for sodium is not the same as hydrogen. Atomic radius naturally down the group, it actually increases. So elements in the same group don't have the same atomic radius, but there's a constant increase in terms of atomic radius. The correct option is the outer shell. The outer shell electronic configuration, because in the same group, all elements have the same valence electron in their outer shell. So that's the correct answer. Question 6 says, how many periods are present in the modern periodic table? The number of periods that are present in the modern periodic table are 7. 18 here talks about the number of groups that are present in the periodic table. Question 7 says, the block to which an element belongs is determined by, A says its number of neutrons, B says the subshell receiving its last electron, and C says its atomic mass, D says the number of its isotopes. I've told you before this class that the particular block that an element belongs is determined by its subshell. I won't say it is subshell, we're talking about the subshell that carries its last electron. For example, if we all know that if I'm to do the electronic configuration of sodium, for example, sodium is 1s2, 2s2, 2p6, and 3s1. Now, that is for sodium. And then let me also do that of magnesium, for example. So, or perhaps aluminium. Aluminium is 1s2. So let me create space here for what I'm about to do. So this is sodium atom, and let's say this is aluminium, and this is 2s2, this is 2p6, this is 3s2, and this is 3p1. Now, what have you noticed? We're talking about the last valence electron, the blocks, the subshell that is carrying the last electron. Now, you should know that in every electron, in every electronic configuration, we have it, let's say, in this manner. For example, this is actually the energy level, and this is the subshell. And the subshell, we have the S, the P, the D, the F. And the highest number of electron that the S can carry is 2. This can carry 6. This can carry 10. And the F block, sorry for this, the F can carry 16. Now, what are we saying? The correct answer to this particular question is actually option B. The subshell receiving its last electron. Look at this particular element right now. The electron, the subshell that is receiving, what's the subshell here? S is a subshell. And the subshell number here is 1. That means this particular element is an S block. Sodium is an S block element. Sodium is an S block element. Aluminium, the last subshell that is receiving its last electron is the P. So it is a P block element. So how do you determine the block an element belongs? You determine that by what? Taking cognizance of the subshell receiving its last electron. All right, we have a question to treat here. An element has the electronic configuration 1s2, 2s2, 2p6, 3s2, and 3p4. It belongs to, A says group 14, B group 14 and period 3, B says group 16 and period 4, C says group 6 and period 3, and D says group 16 and period 3. Which option do you think is correct? Now, it happens that the correct answer to this question, before I give the correct answer, look at this particular element. This 1, 2, 2, 3, and 3 tells you the energy level or the shell that that particular element has. And the shell that an element has sometimes tells you the period that particular element belongs. Since these have actually reached the third energy level, it means it is in period 3. So this is 3s and 3s. So this particular element is in period 3. Based on that, we've established that now all these options have period 3. So it means option B is out, it's not among. Now, for us to now know what group it belongs, we're going to look at, since this element ends with 3p, when this element is actually any element that is a p block, for you to know the group it belongs, this is just the simple idea you need to know. Based on the modern numbering system in the periodic table, you're going to do 10 plus the whatever is the s, whatever s is carrying, the number of electrons that s is carrying, which is 2, plus whatever the p is carrying, which is 4. And in doing that, it's going to be 10 plus 6 is going to be 16. So this particular element is in group 16. So the correct option to that is we're looking for period 3, group 16. So it happens that option D is the correct answer. Now there's something I want you to know that is very important. You know, if we're just dealing with the first 20 elements, just the first 20 elements, sometimes you see them naming elements from group 1 to group 8. If you're just dealing with the first 20 elements, but we're dealing with the modern periodic table, the whole of it, right? So in that modern numbering system, this particular element is found in group 16 as against group 6 based on the first 20 elements, right? Now, question 9 says, which of the following is a p block element? It's very simple. We all know that sodium and calcium, because I told you that every element that is in the group of group 1 is between group 1 and group 2 is an s element, because a lot of their outermost shell electron is borne by the s the s block, right? So sodium and chlorine are actually the x block. Iron here is a transition metal, falls in the category of zinc, manganese, chromium, you know, all of those other elements are transition metal, and most of them are d block elements. The correct option is chlorine. Why is it chlorine? Let us see why it is chlorine based on the p block, because the block of an element, I say, is determined by what? The electron that the subshell that is carrying its last electron. So if we write 1s2, 2s2, we're doing the electronic configuration of chlorine now. 2p6, chlorine is 17, so we have filled 10 already. So now this is 3s2, we have filled 12, and this is 3p5. So ultimately we have filled what? 17. So the correct option is chlorine. Reason being that you see that chlorine, it ends with what? 3p5. So, and it's the only element here that is a p block element, right? All right, question 10 says, which element has the electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2? A says calcium, A says calcium, B says potassium, C says candium, and D says magnesium. The simple way to get questions of this kind of type is to look for the atomic number of that particular element, as the number of protons that element contains. And we can do that by simply counting the number above here, the exponent here. 2 plus 2, that's 4, plus 6, that's 10, plus 2, that's 12, plus 6, that's 18, plus 2, that is 20. So which element has 20 protons in its nucleus? The correct option is calcium, right? Other ones do not have 20 atomic proton in terms of their nucleus. An element with the configuration 1s2, 2s2, 2p6, 3s2, 3p1 belongs to A says group 1, period 3, B says group 3, period 4, C says group 13, period 3, D says group 13, period 2. Now, it's very important for you to know that the highest shell of an electronic configuration determines the period in which that particular element is. What do I mean by that? This number here, this 1, 2, 2, 3, and 3 are the shell, right? Or we call it the energy level, that particular elements. It happens that the highest shell here is 3, and any element that has 3 in terms of its shell is in period 3. So that's the first thing we established. So this element being period 3, then how do we determine the group it belongs? Since this element is a p block element, I've told you p block element, you simply add 10 plus, you pick the last two electronic configuration of that particular element, which is 3s2 and 3p1, and add them together. That's the last 2 valence electron. It's 2 and 1, and add them to 10. So if you add 1 plus 2, it is what? 13. So it happens that this particular element is a period 3 group 13 element. So making option yes, option C is a correct answer. Question 12 says, which electronic configuration represents a group 17 elements? That principle will still help us in answering that question. With a group 17 elements, all you need to do is we're going to add 10 plus what electrons are we going to add up to 10 to give us 17? If we add 2 plus 3, it will give us 15. That is not with that. If we add 2 plus 4, it will give us 16. That does not. This is still 2 and 4. This is 2 and 5. So that is actually the correct option. So the correct option is D. Which of the following is a noble gas? A says neon, B chlorine, C sodium, D magnesium. We all know that magnesium are alkaline metal. Sodium is an alkali metal. Chlorine here are halogens. Neon happens that neon is the only element here that is regarded as what? The noble gas. It's in the group with xenon, krypton, argon. In that category, they are all referred to as noble gases. They are the only group that have octets electronic configuration in their stable state. The next question says the general outer electronic configuration of group 1 is. The general outer configuration of group 1, if you're dealing with lithium, for example, because group 1 we have lithium, we have sodium. Let me make space here so that we'll be able to understand what I'm saying. We have lithium, we have sodium, we have potassium. Lithium is 1s2, 2s1. Sodium is 1s2, 2s2, 2p6, 3s1. Potassium is 1s2, 2s2, 2p6, 3s2, 3p6, 4x1. Yes, that's correct. Now, looking at all these elements that we're seeing here right now, they have something in common. See, one in its atom shell, one in its S1, X1. So these 3, 4, and 1 is our energy level, or we call it a number of shell, right? So in its outermost shell, as the number of shell it has, this means that lithium has 2 shells, sodium has 3 shells, potassium has 4 shells. That's what I'm saying is N is the number of shells, or we call it the energy level of that particular element. NS2 here is for alkaline earth metals such as magnesium, calcium. This is the correct option, NS1. Yes, whatever is the energy level, which could be 2, which could be 3, which could be 4, as the case may be. This is not a group 1, neither is this a group 1 electronic configuration. Question 15 says, which of the following is a transition metal? Chlorines are halogens, so they are out. Sodium are alkali metals. Calcium are alkaline earth metals. That means that the only one that is regarded as a transition metal or element is iron. Next. Which configuration represents an element in period 4? Look at the options and the configuration. You could pause your video and tell me what answer you think this will be. In a very simple way, for you to determine what answer this will be, is to look at the shell or the energy level, the highest shell. This particular element has is a p block element. So the highest level is 2. By it being 2 in terms of the level of the shell, the highest shell is 2. So it means it's a period 2 element. This also, the highest shell or energy level is 2. So it means it's a period 2 as well. This has its highest shell as 3. It means that's a period 3. So the element with the highest shell of 4 is option A, which is what? A period 4 element. So this is a correct option because it has the highest shell as what? 4. The next question says, which element belongs to the same group as oxygen? A says fluorine, B says nitrogen, C chlorine, D sulfur. We all know that fluorine and chlorine all are referred to as halogen. They belong in the same group, although different period. Nitrogen here is a group 15 elements. How do we know that? 1s2, 2s2, and 2p3 is the electronic configuration of nitrogen. And I told you that the moment you see an element being a p block element in the modern numbering system, you simply add the 2 electronic configuration of that particular element. Just add it, just add 10 to it. So this is a p block element. You're going to say 2 plus 3, which is what? 5 plus 10, that's 15. The only option that is correct here that is in the same group with oxygen is sulfur. The both of them are in group 16, and they collectively form an electronic configuration as Ns2 Np6. That's towards the end of their valence electron configuration. All right, so the next question says that which pair contain elements in the same period? A says lithium and sodium, B sodium and magnesium, C fluorine and chlorine, D sodium and potassium. We all know that lithium and sodium are in the same group because they all have an valence electron of +1. Fluorine and chlorine also are in the same group. All right, they are regarded as halogen. Sodium and potassium are also in the same group. The only one that is in the same period here is sodium and magnesium. That is period 3. So it happens that B is a correct option. Now 19 says the lanthanides and actinides are collectively known as A says halogen, B says representative elements, D inner transition elements, and D noble gases. Noble gases are group 18. We all know that halogens are group 17. They are not representative elements either. The correct option here for lanthanide and actinide are inner transition elements because they actually fill up the F subshells, right? And they are from the F blocks. Okay, so the correct option is option C. Question 20 says that hydrogen is placed above group 1 mainly because A says it's a metal, B says has 1 electron, D says form only negative ion, and D says has 1 valence electron. We all know that, very importantly, to define what qualifies an element to be in a particular group is subject to its valence electron. The valence electron of every element determines their stay in every group. And hydrogen is well placed in group 1 because, not because, of course, hydrogen is not even a metal, it's a non-metal. All right. Hydrogen is between group 1 and group 17. For group 17 are non-metals. They are looking for 1 valence electron to complete their outermost shell. Hydrogen is between group 1 and 17, but it is placed in group 1 because of the 1 valence electron it has. All right, so very important for you to note that. All right, so they say atomic radius generally decreases across a period because these are the options. More electron shells are added. B says nuclear charge increase while electron enter the same shell. And C says the same number of proton decreases, and D says shielding increases greatly. Let me use period 1 as an example of this particular question. Let's say this is okay. This is hydrogen and this is helium. Now, as we move from the left towards the right, remember that in the periodic table, elements are arranged based on their atomic number. So as we move from left to right, there's an addition of proton, as in there's an increase in terms of the atomic number. As the atomic number of the elements increases across the period, their size reduces. What causes that reduction? Hydrogen here has a +1 charge, right? Helium here has a +2 charge. The more electropositive or the more proton that you add to a particular element, the more tendency it has to be very attractive to the electron in the outermost shell. These electrons are negatively charged, so it will cause a pull, because as you increase the number of proton in the nucleus, it will want to react much more with the electron in the outermost shell, which are negative. Remember, electrostatic, on like terms repel, on like terms attract. So this is positive proton in the nucleus and negative in terms of its electron. So the more positive or the more proton you add to an element, the more tendency it has to pull those electrons to the center. All right. Now that pull will lead to what? A shrink in the size of that particular atom. So across the period, note it very well that the more protons you add to a particular element, the more tendency it has to react with the electrons, which are negatively charged, and that will actually cause a strong pull, a strong nuclear pull of those electrons. You want to pull it to the center, and that pulling will cause that electron to shrink, to reduce. So across the period, from left to right, the atomic radius decreases. It's only down the group that there's an increase. So looking at this option right now, this says shielding increases greatly. Now, the shielding effect across the period is constant. It's constant in a sense that it's the same shell that electrons are being added, because in group 1, they are all one shell. In group 2, it's just 2 shells. In group 3, across the period, all of them are having 3 shells. So the shielding will not increase across period. It will be constant, because it's the same shell that you are adding those electrons to, right? So nothing will happen to the shielding. Option C says the number of proton decreases. That's not true. Across the period, there's an addition of proton. Lithium moves to magnesium, magnesium moves to aluminum. So you see there's an addition of proton. So it increases, not decrease, across the period. A says more electron shells are added. Across the period is the same number of shells that goes across every period. So there's no addition of shell. All right. So the correct option is nuclear charge increases while electron enter the same shell. That's correct. What you need to know is that what increase across the period is the nuclear charge. This is +1, this is +2. Lithium is +3, sodium is +1, sodium is +1, magnesium is +2, aluminum is +3. You see, so nuclear charge was increased. Why? It is the same shell. The next question says atomic radius increases down a group, mainly because A, new electron shells, B, nuclear charge becomes 0, and C, electronegativity increases. Let's start with this. One thing you need to know that is very important is that electronegativity and also ionization energy are all opposite to what ionic radius does. Ionic radius decrease across the period, but it increased down the group. Electronegativity, on the other hand, and even ionization energy, they do opposite of what ionic radius does. If ionic radius is decreasing across the period, they increase across the period. And if ionic radius increases down the group, they reduce down the group. So electronegativity increases down the group is out of it. That's wrong. And then option D says the number of proton decreases down the group. Proton is increasing also. You see, because if you're looking at group 1, for example, you have hydrogen that has a +1 or 1 proton. The next is lithium that has 3 protons. The next is sodium that has 11 protons. So you see there's an increase in protons. So option D is also out of it. Option B says nuclear charge becomes 0. Now that's not true, because the the charge of each of the elements in group 1 are +1 in terms of their charges, right? So it's not 0. So the correct option is new electron shells. New, because as you go down the group 1, for example, lithium has 2 shells, sodium has 3 shells, potassium has 4 shells, as just like that down the group. So you have to take cognizance of that. So option A is correct. The next question says, which atom has the largest atomic radius? Largest atomic radius. Lithium, sodium, rubidium, potassium. Now, what you need to know is that all of these elements are electropositive. Now, remember that ionic size increase down the group. Sorry, atomic radius rather, not ionic size, pardon me. Atomic radius increase down the group while it decrease across the period. And if it increase down the group, in group 1, we have lithium followed. Okay, let's start with this. The first element here is hydrogen, seconded by lithium. Third is sodium. Then we have potassium, and then rubidium. So if atomic radius is increasing down the group, it means that hydrogen is less than lithium. And lithium is less than sodium. And sodium is less than potassium. And potassium is less than rubidium, right? So in terms of highest atomic radius, rubidium is the highest element, all right? Is the element with the highest atomic radius, followed by potassium, followed by sodium, and then lithium, and then last hydrogen. So the correct option here is rubidium. Which period 3 element has the smallest atomic radius? First of all, you have to look at the period. Remember that across the period, what happens to the atomic radius? It decreases. I believe you got it right. It decreases. So across the period, we have sodium, then we have magnesium, then we have aluminum. You see, the next you will be able to see chlorine also follows in that same manner. Chlorine is also in group 3. So if you notice from left towards right, the atomic radius reduces or decreases as the case may be. So across the period, across period 3, which element in period 3 has what the smallest atomic radius? Since there's a decrease going this way, so the element that has the smallest atomic radius is going to be chlorine. We'll go to the next. All right, question 25 says, the energy required to remove the most loosely held electron from an isolated gaseous atom is called A is ionization energy, B is electron affinity, C electronegativity, D bond energy. We all know, I believe you know what that is. Electron affinity is simply the gain of electron. Electronegativity is how much electrons an element actually contains. The correct option there is the ionization energy. It tells us the energy that is required to remove an atom that is loosely held in the outer shell of an electron. Now, the next question says, first ionization energy generally increase across a period. Now, you need to know this. Whatever happens to the ionic radius is opposite to what happens to the first ionization energy, all right? So across the period, the ionization energy increases, but down the group, it decreases. Now, looking at this right now, they say the first ionization energy generally increases across a period because A says atomic radius increases. That's not true. We all know that across the period, atomic radius what decreases. So this option is totally out. Metallic character increases. Metallic character does not increase. This option D. Metallic character is the ability, simply elements that can actually conduct electricity. They readily react with other non-metals to form ions, right? So metallic character from left to right, that's across the period, it actually decreases. Reason being that you're moving from metals, which is alkaline metals, to alkaline earth metals, you're moving to metalloid, you're moving to non-metals on the right-hand side of the table. So metallic character does not increase across the period, it rather decreases. Another thing, B says shielding increases greatly. Across the period, shielding is constant. Why? Because we have the same number of shells across the period. Group 1 has 1 shell. Sorry, period 1 has 1 shell. Period 2 has 2 shells. Period 3 has 3 shells. So across the period, we have the same number of shells. So you're just adding electron to the same shell, not another shell that is added up. So it is down the group that the shielding effect actually increases. All right, so that's out of it. The correct option is effective nuclear charge increases. Yes, first ionization energy generally increases across a period, because we all know that the only thing that is true here is that truly that effective charge actually increase across a period. 27 says first ionization energy generally decreases down the group because A says nuclear charge becomes 0, B electronegativity increases, atomic radius increases, the outer electron becomes farther from the nucleus and more shielded. What do you think is the right option? Now, remember that first ionization energy down the group, it decreases. It's across the period that there is what increase in terms of the what first ionization energy. Now, what you need to know in essence is that they say down the period that nuclear charge becomes 0. That's not true. We know that down the period, or down the group rather, especially across, let me say group 1 element, C +1 charge across it. So it's not 0. B says electronegativity increases. Electronegativity does not increase across or down the group rather. It only increase across the period. Now, take for example, rubidium. Rubidium is more electropositive than potassium of the group right now, right? So, and also, okay, now let's also look at electronegative elements. Let's look at group 17. Fluorine, for example, in group 17, those elements are actually electronegative, and fluorine, which is at the top, is more electronegative than fluorine that is down that particular group. So across the group, or sorry, down the group rather, electronegativity does not increase, it rather decreases. Atomic radius increases. Yes, atomic radius increase down the group, but it is not the main reason for first ionization energy decrease, right? So the correct option is option D. I'm sorry, this is not electron. Electron is just electron. The outer electron becomes farther from the nucleus and more shielded. That is to say that the more distance and more shielded an element is, it weakens the outer shell and it makes it easy to be pulled off. All right. So that easy input of weakens ionization energy going down the group. You understand? So what you need to understand is very, very important, that the farther away an electron is from the nucleus, the easier it is to pull it out of that particular electron, or out of that particular element, right? So option D is correct. Next question says, which element has the highest first ionization energy? A says sodium, B says magnesium, C says chlorine, D says ionization. What do you think the option or the correct option to this question will be? Now, it happens that they're talking about the element that has the highest first ionization energy. What you need to know is that first ionization energy generally increases across the period, right? And if you notice, all these elements that are listed here are all period 3 elements, all of them. So if you move from sodium, you go to magnesium, you go to aluminum before you now get to chlorine. So it means chlorine has higher first ionization energy than the other elements. And also, you also need to understand that chlorine that needs 1 electron in its outermost shell will hold its 7 valence electrons stronger than sodium and magnesium and aluminum, that has just, this is +1 in its valence electron, this one has 2 in its valence outermost shell. This one has +3 outermost shell. So the element that has 7 valence electron hold it tightly than these other ones that have less valence electron in their outermost shell. So across the period, ionization energy increases. So chlorine is the correct option in terms of highest first ionization. Now it says, which element has the lowest first ionization energy? What you need to know is that, normally ionization energy decreases down the group. It decreases down the group. Notice that lithium, sodium, potassium are all in the same group. Beryllium is in group 2, yes, but then we're going to actually use this as a guide. And also very important for you to know which one has the lowest ionization energy, you look at how much of shell does it have. It happens that across, in terms of all of these elements that are here, potassium is the one that has the highest number of shell. And the more shell it has, it increases in its atomic size. Now, if it increases in atomic size, the electron in the last shell will be loosely held. All right, so it will be easy for it to be pulled out. All right, it will be easy for it to be pulled out. And also the distance of that electron from the nucleus is far away, so it has low ionization energy, and the outermost valence electron for potassium will be easily pulled off than it is for sodium and lithium, even though they are in the same period. Beryllium also has high ionization energy because it has 2 valence electrons, so it will hold it more closely, and it has less, the atomic radius is not as large as that of potassium. So the correct option is potassium. All right, electronegativity is the ability of an atom to, A says, attract shared electrons in a chemical bond. B says, release energy when it gains an electron. C says, lose neutron. D says, remove an electron completely from another atom. Electronegativity does not remove electron completely from another atom, and it doesn't release energy when it gains an electron, right? Doesn't lose neutron either. So the correct option is attract shared electron in a chemical bond, right? Very importantly, for electronegativity to become electronegative, the ability of an atom to attract. That's what it does. It attracts electrons. It shares electrons from other elements as well. So the correct option here is option A. This question says, electronegativity generally increases across the period. Now you need to know something about electronegativity. Electronegativity does opposite of what atomic radius does. We all know that atomic radius increases only down the group, but decreases across the group. Electronegativity does the opposite. It increases down across the group. So that across the period, it increases across the period and then decreases down the group. That is electronegativity. Now, what you need to know, they say electronegativity generally increases across a period because, and the reason for that, A says metallic character increases, B says atomic radius increases, C says shielding increases greatly, D says effective nuclear charge increases. The first thing you need to know is if it is across the period, metallic character does not increase across the period. If it's moving across the period, that is from left towards right. When anytime you hear the word across the period, it's from left to right. And you're moving from metals towards non-metals. So metallic character decreases. So this one is out. That's not the answer. Atomic radius increases. Across the period, we all know that atomic radius decreases. It doesn't increase. So that's also out of it. Shielding increases greatly. As long as it's across the same period, there is no addition of a new shell. The shielding will not change, not increase or decrease. It just remain constant because it's just addition of electrons. You're not adding a new shell. So shielding does not change. So the correct option is effective nuclear charge increases. Of course, there's addition of protons. So the effective nuclear charge across the period increases generally. So option D is correct. Next question says, which element is the most electronegative? Is the most electronegative? The electronegativity of elements increases across the period and decreases down the group. So looking at this particular element right now, the most electronegative element there is in the periodic table is fluorine. Although fluorine has a favorable ability in terms of electron gain or electron sharing than fluorine. Or fluorine is regarded as the most electronegative element that you need to know. Question 33 says, electronegativity generally decreases down a group because A says ionization energy increases, B says atomic radius and shielding increases, C says the number of occupied shells increases, and D says atomic radius decreases. Now what you need to know in essence is that as long as it's down the group, ionization energy is decreasing, because when you're going down the group, there is addition of new shells, so making the ability for ionization to occur very little. The electrons that are in the outermost shells of the element that are down the group are easily pulled off, so there is decrease in the ionization energy down a group. So A is out of it. Ionization energy does not increase down the group, it rather decreases. Atomic radius, okay, before that, because this is actually a correct option, option B is a correct answer. Let me take it first. C says the number of occupied shell increases. Sorry, the correct word is decrease, not increase, please. My bad. C says the number of occupied shell decreases. We know that down the group, shell increases, it doesn't decrease, so that's out of it. Atomic radius decreases down the group. That's wrong. It increases down the group because there's actually increase in the number of shells that are added up. So the correct option is option B, which says atomic radius and shielding increases. That's true because as you move down the group, the electrons are more bonded together, and then it increases the shielding effect. The first says, which element has the greatest metallic character? A says potassium, B says lithium, C beryllium, D sodium. We need to understand something about the metallic character. The metallic character, from right to left, it increases, but from left towards right, it decreases, because from right to left, you're moving from metals towards, you're moving from non-metal towards metal, but from left towards right, you're moving from metal towards non-metal. That's one thing. Then number two, metallic character also increase down the group. Increase down the group. So the more you're going, the more the metallic. Remember, metallic character refers to the ability of metals to actually react with non-metals and then form ions. So if you notice, the more electropositive the metal is, the more its metallic character. So looking down the group, the element with the highest or the greatest metallic character is potassium, because potassium is down the group and it is more electropositive and therefore has a greater metallic character than sodium, lithium, and beryllium. The 5 says metallic character generally decreases across a period because A says atomic radius increases, B says nuclear charge decreases, C says ionization energy generally increases, and D says atom lose electron more easily. If it's across a period, there is actually a gain of electron, not loss of electron, because you see from hydrogen to helium to lithium to just across the ladder to beryllium to boron. There's just a movement, an increase in terms of the atom. So D is not correct. A says atomic radius increases. Across the period, we all know that atomic radius decreases, not increase. So that's off. B says nuclear charge decreases. If it is across the period, as long as elements gain electrons, there is going to be increase in the nuclear charge across the period. So nuclear charge decreases is totally off. So the correct option is ionization energy generally increases, because across the period, as elements tend to gain electrons or they tend to gain protons, there's actually going to be, they're going to hold their electron more closely, unwilling to give it off. All right, so the correct option is ionization energy will generally what increase. That's what enhance, that's what's lead towards decrease in the metallic character. Okay, that says that which period 3 elements is the most metallic? A says silicon, B says magnesium, C says aluminum, and D says sodium. Now the word metallic, you need to know that metallic character, if you're moving from left towards right, there's going to be a decrease because you're moving from metals towards non-metals, right? If you're moving from right towards left, there's going to be an increase in the metallic character or the metallic ability of elements, right? So left to right, decrease, right towards left, there's what? An increase. So if you're moving from right, dealing with the group period 3 elements, you're going to go through silicon, then you meet aluminum, then you meet magnesium, and then meet sodium finally. So sodium is the most metallic element in terms of period 3. Electron affinity refers to energy when A, an isolated gaseous atom gains an electron. B says an electron is removed from a gaseous atom. C says a proton is added to the nucleus. And D says a covalent bond is broken. We all know in simple terms, when you hear the word electron affinity, is simply gain of electron. So the correct option is option A. 38 says, which element has the most favorable electron affinity? Neon, magnesium, chlorine, or sodium? Now, electron affinity is more like the gain of electron. It happens that neon is already in its stable state, so it will not need an electron to make any reaction. Magnesium, neither. Sodium, neither. Chlorine, since it's very, very electronegative, is going to actually have the highest, most favorable electron affinity ability. So, the correct answer to this is B, chlorine. 39 says a shielding effect is mainly caused by A says valence electron only, B says neutron, C says proton, D says inner shell electron. When you hear the word shielding effect, what causes that is the inner shell electron. Inner shell electron reduces the ability of a nuclear pool, like reduces the pull or the attraction of electron to the center of the nucleus of an atom. So what enhances shielding effect is particularly the inner shell electrons, right? So you have to take cognizance of that. So option D is correct. Question 40 says, shielding effect generally increases down a group because A, atomic radius decreases. Take B says proton number increases. C says additional occupied electron shells are added. D says nuclear charge becomes smaller. We all know that atomic radius does not decrease down the group, so that option is off. Option B says proton number increase. Oh, sorry, it's not increase, it's decrease. That's a mistake from my end. Proton number decreases. C says additional occupied electron shells are added, and D says nuclear charge becomes smaller. We all know that down the group atomic radius increases, not decrease, so this is off. Proton number decreases. Down the group there's addition of proton, right? Elemented to increase in the atomic number, which is addition of proton. So option B is off. Option D says nuclear charge becomes smaller. Down the group, nuclear charge actually doesn't become smaller. It's also constant maybe across the group, but the correct option is option C. Additional occupied electrons are what added. That's what leads to shielding effects, right? So option C is a correct answer to this question. Now let us quickly do a recap of what we've done thus far in terms of periodic trends. You're going to tell me the direction it increases. Atomic radius increases in two ways. First is down the group. We all know it's down the group. And where do you think is the next direction that will cause atomic radius to increase? Atomic radius reduces going from left to right. Right? So if you're coming towards left, then it's increased. So atomic radius increase in two directions. It is down the group and when you're moving towards the left side of the table. Ionization energy, can you tell me the direction of its increase? Down the group, it decreases, so it will be up the group. And where else do you think? Yes, you're right, and it will move right of the table. So if you're going towards right, ionization energy is increasing. And so if you're going up the group, the ionization energy also what? Increases. Next is the electronegativity. Can you tell me the two ways in which it increases? Electronegativity increase up the group, right? Up the group, and it also increases towards the right of the periodic table, all right? So metallic character we all know, In terms of group, where does it happens that metallic character increases down the group? And it's in terms of right or left, where is the place of its increase? Metallic character increase towards the left of the table. When going towards the left, it increases. How about the shielding effect? All right. Remember that either left or right, the shading effect does not increase or decrease. It is constant. But there's only one point of for which the shielding effect increases, and it is down the group. I want to generally tell me the point of decrease for each of these on the comment section. I want to test your ability. Write for me on the comment section. Where does atomic radius decrease to? Ionization energy, when does it decrease? Electronegativity, when does it decrease? Metallic character, tell me when it decreases, as well as the shielding effect. And then we go to the last set of questions. All right, question 41 says, which statement about a positive ion is correct? A says it is usually smaller than its parent atom. B says it is formed by gaining electron. B says it has more electron than proton. D says it is always larger than its parent atom. Now, when you hear the word a positive ion, they are trying to compare positive ion with its atom. So, for example, let me create space for something here. We have, this is sodium atom, and this is sodium ion. It happens that when an element is actually in its ionic state, is losing that number of valence electron. Since sodium ion is positively charged, it's going to lose one electron. And if it loses one electron, it's going to reduce in its atomic radius. It's going to reduce the number of electron that it contains. So generally, what you need to know is that elements that are electropositive in their ion, they tend to be less compared to their atom. That means that an electropositive atom, sorry, let me put it this way. How many electrons are here in sodium? There are 11. How many electrons are here? It is 10. How is it 10? It loses one. So the general thing you need, the general formula you need to apply in terms of calculating, let me take this out. The general formula you need to know for you to get the number of electron, you're going to do the atomic number. Sorry, I'm writing this in. The atomic number minus the charge. So sodium has a charge of +1. The atomic number of sodium is 11 minus, this is +1. If plus times minus, it will become 11 minus 1, which will be equals to what? 10 electrons. So generally, when elements are positively charged, their ions are going to be less compared to their atom. So sodium atom has more electron and is bigger than what? Sodium ion. How about, okay, so let us quickly go into solving this question before I go to the next. So the correct option, they say it is usually smaller than its parent atom. Is it true that a positive ion is smaller than its parent atom? It happens that the answer is correct. Yes. So the correct option here is A. This says it is formed by gaining electrons. No, positive ions don't gain, they rather give out. All right. It has more electron than proton. That's not the case. The number of proton in the atom of sodium is more than the electron it has. This says it is always larger than its parent atom. Reverse is the case. It's not always larger than its parent atom, rather it is smaller compared to its parent atom. So the next question says that which statement about a negative ion is correct? A says it contains fewer electrons than proton. B says it is formed by losing electron. D says it is usually smaller than its atom. D says it is usually larger than its parent atom. Now, If electropositive ion are reduced or they give out their electrons, what happens to electropositive, electronegative rather? They are actually going to what? Gain electron. So cations, let me make this statement. Cations, when we say cations, these are electropositive, right? Cations are usually less compared to what their parent atom. While anions are greater than what their parent atoms. For example, if we are dealing with, let me take off this. If we are dealing with chlorine, for example, this chlorine atom and this is chlorine ion. This chlorine ion is going to gain one electron. And I've told you the formula you apply in getting the total number of electrons will be the atomic number minus the charge. And if you do if this is the electron and it's given as the atomic number minus the charge, it happens that the atomic number of chlorine ion is 17 minus, there's a negative 1 here. All right. So negative and negative to become what? 17 plus this, so it becomes 18. So to become what? 18. So the number of electron is going to increase. So let's come back to our question. Which of them do you think is correct? Is it true that it's usually larger than its parent atom? Obviously. The negative ion is always larger than what? Its parent atom. So it happens that this is the correct answer. It is not usually smaller than its atom. It's not formed by losing electrons. It's actually formed by gaining electron. It contains fewer electrons than proton. No, because it gains electron, it becomes electronegative. So it actually has more electron than proton, not fewer. The next question says that which comparison is correct? Which comparison is correct? That sodium ion is greater than sodium atom, or sodium atom is greater than sodium ion, or sodium atom is equal to sodium ion, and this says their sizes cannot be compared. What do you think is the right answer? It's obvious from what we've explained that ions that are electropositive are small compared to their parent atom. So sodium ion is not greater than sodium atom. This is wrong. Sodium ion is not, yes, sodium is greater. Sodium atom is greater than what? Sodium ion. That's correct. Sodium atom is greater than sodium ion. You have to take cognizance of that. Very important. Next question says that which comparison is correct? Chlorine atom is greater than chlorine ion. Chlorine atom is equal to chlorine ion. Chlorine ion is greater than chlorine atom. Chlorine ion has fewer electrons than chlorine. Which option do you think is correct? I believe you've chosen the right answer. A says chlorine atom is greater than chlorine ion. That's not correct. We all know that if it's an anion, that's an electronegative ion. It's going to actually have more electron than its parent atom. It happens that the correct option is option C. The ion, a negative ion is larger than its parent atom. So that's the correct answer. Which pair is isoelectronic? A says sodium ion and neon atom, sodium atom and neon sodium ion, magnesium atom and neon atom, chlorine atom and argon atom. What do you think is correct? We all know that the total number of isoelectronic means same electron. And if you notice, the combination or the pair that have the same number of electrons is option A. because this sodium ion is actually going to lose one electron and become 10 electron, and neon is already 10 electrons, so making it isoelectronic, means same electron. So the correct option is A. Order 46 says, which set contains only isoelectronic species? We have sodium ion, magnesium atom, and aluminum ion. We have oxygen ion, fluorine ion, neon atom, and sodium atom. We have oxygen atom, fluorine atom, neon atom, and sodium ion, sodium atom rather. And D, we have chlorine ion, argon atom, and potassium atom. Let me make space here above so that we'll be able to explain this concept very well. So the word isoelectronic, we've all established that it means same number of electrons. So let's look. The first option, let's try the first option. Sodium ion, how many electrons does it have? It has 10. And we know how we came about it, right? It loses one. Normally it's supposed to have 11, but it loses one. So it has 10 electrons. Then magnesium is 12 electrons. Aluminium, we know that aluminium ion is going to be 10 electrons as well, but one of them is higher than that. If magnesium was actually in its ionic state, it would have been isoelectric, but that's not the case. So option A is not correct. Let's try option B. Option B says oxygen, fluorine, neon, and sodium. So we have sodium. Sorry, on this is actually sodium ion, not sodium atom, please. So we have sodium ion. So let us check. Remember that oxygen is actually having 8 valence electrons. And because it's electronegative, it will attract 2 valence electrons to itself, making it gain 2 more. So it's going to become 10 electrons in total. So oxygen is 10 electrons. Fluorine is also have 9 valence electrons. This is electronegative. It's going to gain 1 electron to itself and it will become 10 electrons as well. Neon is already 10 electrons in terms of its atomic state. Sodium ion will lose 1 electron and also become 10 electrons. You see? So it means option B is a correct answer because all the ions and atoms in this particular options are all isoelectric, meaning they have the same number of valence, same electron. Other options are wrong. We're done with that. We'll go to the next set. All right. In an isoelectronic series, ionic radius generally decreases as A says mass number decreases, B says number of neutron increases, C says nuclear charge increases, and D says number of electron increases. Now, one of the things you need to know that is very important is that the word isoelectronic series, now note all of them have the same valence electron. All of them are the same electron. So what will you use to determine the decrease in the ionic radius? What we use in determining that is the elements, the number of proton. The number of proton will decide which element is actually going to reduce in ionic size. So it happens that the elements that have more proton in their nucleus will tend to reduce or squeeze or do what they call the nuclear pull. And in that nuclear pull that it will do, it will actually reduce the size of the ion. All right. So it is the nuclear charge increase that leads to a decrease in the ionic radius, right? So very importantly, you need to know that anything has to do with ionic radius decrease, it's actually as a result of what? The increase in the nuclear charge, right? All right, 48 says, which species is the largest? Magnesium ion, sodium ion, fluorine ion, or oxygen ion? Now, in terms of ionic radius, that's ionic size, it happens that the size of ions are determined by the number of protons that they contain. Now, if an ion has less proton, it's going to be larger because it will exert a very little pull of the electron to the center of the nucleus, right? So mark that idea that the more proton that an ion has, the more tendency it has to reduce in its size. And the less proton ion has, the more tendency it has to be large. So looking at these four ions, the one that has the least proton is oxygen, followed by fluorine, third by sodium, and last by magnesium. So in terms of least proton, oxygen, let me write it this way. Oxygen ion is greater than fluorine ion, and fluorine ion is greater than sodium ion, and sodium ion is greater than magnesium ion in terms of ionic size or ionic radius, right? So it happens that the correct option here is option D. I hope you remember. All right, question 49 says, why is the first ionization energy of magnesium greater than that of aluminium? These are the options that are given. It happens that, let's say magnesium has fewer. Okay, let's start from A. The electron removed from aluminium is in a higher energy 3p subshell. This is aluminium has a completely filled p subshell. This C says magnesium has a larger radius, and this says magnesium has a fewer proton. It happens that the correct answer to this question is option A. Reason being that if you're writing the last electronic configuration of magnesium and sodium, magnesium, because it's a group, a period, two elements, it's going to end with this is magnesium 2s2 2p6, this is 10, and then 3s2. Then if we are looking at, let me make space here. Oh, I've cleaned up what I wrote, so let me write it. 1s2, 2s2, 2p6, 3s2. This is for magnesium. Then aluminium, 1s2, 2s2, 2p6, 3s2, 3p1. Now, one thing you need to know that is very important is that the correct answer says the electron removed from aluminium is in a higher energy 3p subshell. Now, because it's in a higher energy level 3p subshell, the first ionization energy of magnesium is greater than that of what aluminium. That's to say that the 3s here, the s orbital here will be easily removed compared to the 3p1, making the ionization energy of magnesium greater than that of what? Aluminium. Very important for you to note. Why is the first ionization energy of nitrogen, that's question 50, of nitrogen greater than what? Oxygen. It says nitrogen has a complete outer shell. We know that that's not true because according to in the electronic configuration, oxygen does not have an octet state here, so it's not get complete. So option A is out. B says nitrogen has a stable half-filled 2p shell. Then that's option C, that's option D. Now it happens that anytime you hear a comparison of nitrogen and oxygen, the correct option is always the option B, that says that nitrogen has a stable half-filled 2p shell. And if you're doing the electronic configuration of nitrogen is 1s2, is 2s2, and then you have 2p3. Remember, to fill this p shell, you need 6. So it's already at a halfway point, and so it will have a higher ionization energy, like we easily a higher ionization energy compared to what? Oxygen. So the right thing you need to know is when you're comparing nitrogen in terms of ionization, you compare nitrogen to oxygen, always remember that nitrogen is greater than what? Oxygen. And the reason is because of what? Nitrogen has a stable half-filled 2p shell. All right, we've come to the end of the 50 high yield question on periodic table. And before I give you the final table summary of some cases you need to know, I have the final rapid fire bonus challenge questions here for you. There are just 4 of them. I want you to attempt them and drop the answer for me in the comment section. It's going to be a little gift for the first 5 people to get it all correct. Thank you. All right, just before we call it a wrap-up, I want you to look at this final high yield summary. You have to know the properties and what happened across the period and down the group. This is a summary of it. And also very important, you should also note the essential size rules. These are the essential size rules that I've written here. What cation and anion is to the apparent atom and what isoelectronic series imply. You should also be able to look at some major exceptions, even though some of these rules, these periodic trends cut across these periodic tables, there are some certain exceptions that you need to know, right? And these are the exceptions. Beryllium has a higher phase ionization energy than boron. Aluminum has a higher phase ionization energy than aluminium, and so forth. The last one there is chlorine has a more favorable electron affinity than what? Fluorine. So these are key things that you need to know very importantly. And that we've come to the end of this 50 chemistry high yield question. I want you to score yourself in the course of the video. How many were you able to get by yourself even before I had it solved? And I believe if you're able to score 50, between 45 to 50, that's an excellent one. To score between 40 to 35, that's fair enough. Between 35 to 30, that's medium. You have to just score very well, all right? I believe you for that. Lastly, very importantly, having been guided by all of this and you've learned so much, I beg you to do well to like, comment, subscribe, follow us, and do well to share this video to your colleague and classmates. This could actually help them in preparation for their chemistry exam. And also, very importantly, the last topic to look out for inside tutorials is organic nomenclature and functional group, and we'll also treat their corresponding high yield CBT questions. Keep watching inside tutorials. See you again. My name is Peter Ogbaji. Nice having you around. Goodbye.